I want to summarize what we learned, right? Please, for the exam, study the plant tissue culture. I have to upload it. I didn't upload it. I will upload it. Please study plant tissue culture. It is really an important subject, right? Sometimes it may be hard to you because you didn't do the practical, right? If you visit the lab, you can understand, right? What is the real tissue culture techniques, right? Mainly that micropropagation. And the definition on the thing, why the tissue culture is important, all the things you know it, right? Then you have studied the types of tissue culture, what is thallus, right? What are the, how to prepare that thallus cultures, right? Those things you have studied. And organ culture, what is organ culture? What is single cell culture, cell suspension culture, embryo culture, anther culture, pollen culture. There are so many cultures, right? Protoplast culture, shoot tip and meristem culture. You studied, right? And that stages of micropropagation, we have studied 5 stages: stage 0, stage 1, 2, 3, and 4, right? Stage 0 normally, that is pre-propagation stage. In that stage, actually, we prepare the mother plant, right? We excise the explant from the mother plant. Those are the steps we are doing in the stage 0, right? Just prior to propagation, what we'll do. That is actually a preparation stage. Stage 1, right? Just we want to establish the sterile culture, right? Sterile means aseptic, without contamination. Just we establish a new culture, right? And from that we have to inoculate the explant in the culture medium. That explant starts to make small shoots, right? And shoot proliferation occur in that stage. Stage 2, that is the third step, multiplication, right? Multiplication. At the same, the shoot starts to multiply further and further, and it starts to elongate, right? That is in the stage 2, right? So during the multiplication and elongation stage, we have to do the subculture. 6 weeks interval, 8 weeks interval, it's up to the multiplication rate and elongation rate, right? We have to do the subculture. Subculture, just what we have to do, we have to divide the shoots, right? We have to divide it. It found as a mass, right? So we have to divide it, right? Divide the shoots. We have to cut by scalpel, and we have to separate it, and we have to take each and every small shoots, and we have to inoculate again in a fresh media, right? The newly prepared media, we have to inoculate it, right? That is in the stage 2, right? And from that single shoots, then in a small bottle, we can inoculate 4 or 5 single shoots we can inoculate during one subculture. From the single shoot, when we after few weeks, 2-3 weeks, we can observe from the single shoots it again starts to multiply, right? From that we can get more than 10-15 shoots from the single shoots. Again we have to take out. All the things should be done under the laminar flow, right? We have to take out, and we have to again separate it into single shoots, and again we have to inoculate them, right? Likewise, we do the subculturing until that particular shoots reach the proper height, right? Thereafter, in the stage 3, we are going to transfer them in the rooting media, right? For the in vitro rooting or ex vitro, whatever the rooting media rooting, we can adapt it in vitro, ex vitro. We have to inoculate them in the rooting media. right? Rooting media, you know, auxin is important for the rooting. So we have in that medium, if it is in the MS media, along with the MS media components, we have to add auxin. Mostly naphthalene acetic acid and indole butyric acid are used for the rooting, right? We have to add it, and then we can observe the roots after few weeks. The root starts to initiate. Rooting is actually a very hard step. It's not an easy step to get the roots from the in vitro shoots until we correctly formulate the media, right? And the fourth step is the acclimatization. These are in vitro shoots, right? In vitro rooted shoots. Those cannot be directly transferred to the outer environment. So partial exposure to outer environment should be done, right? That is the acclimatization. We are hardening the in vitro shoots. We called plantlets, right? Then we can again transfer to greenhouse or open field condition, right? This is the stages of micropropagation, right? And the plant tissue culture media, we have studied, there are 4-5 media, basal media. How do we call these? Basal media, Michigan Skewch medium, Linsmeyer Skewch medium, Gamborg medium, niche and niche medium, right? There are several WPM, wood plant medium. There are many mediums, growth plant tissue culture media are there, right? The most commonly used one is the MS one. Okay. Michigan Skewch, they formulate that media in 1962. Right, that is the one we are using with the small modification. Right, for an example, for the rooting, half concentration of each nutrients are added. Right, for the rooting, no need to go with the full concentration. Half of the concentration we have to add it along with the auxin, right? So small modification we can do it, right? And the basal MS media. These are the media composition, right? Macronutrients, micronutrients, vitamin, amino acids, carbon source, sugar, table sugar, or sucrose is a common one. Instead of sucrose, we can use table sugar. Undefined organic supplements like coconut water, right? Orange juice, tomato juice, whatever we can use it, right? Then we called undefined organic supplements. And the growth regulators, solidifying agents, right? Growth regulators, you know, auxin, gibberellin, cytokinin. These are the 3 important plant growth regulators used in the plant tissue culture. Macronutrients, you know, other than that is carbon, hydrogen, oxygen. For the growth, we need nitrogen, phosphorus, potassium, calcium, magnesium, sulfur. So for the macronutrients, we are going to prepare 2 stock solutions, stock A and B, prepared for the macronutrient, prepared with the macronutrients. I will tell you, right? Micronutrients, iron, manganese, zinc, boron, copper, molybdenum, right? And these are the widely used micronutrient. And the carbon and energy source, since the lactose, galactose, maltose, starch are used, the most efficient one is sucrose, right? 2 to 5%. Very commonly used one is a 3%. 3% means for 1,000 liter of basal media, if you are going to prepare, we have to add 30 gram of sugar, right? Now, I told you earlier, instead of sucrose, we use sugar, right? for the, how do we, just think for the 3% mean, right? 30 gram, type it, 30 gram in 1000 milliliter media. That is the meaning, right? 3, just divide 30 for 1000, 30. Then for 100, 3%, right? In which means 3 gram in 100 milliliter. Out of 100, 3 is needed. That is 3%, right? So other carbohydrate, as I already told you. So we have to prepare we have to add all the stock solution which contains that macronutrient, micronutrient, vitamin, right? And we, in addition to that, we have to add the energy source, right? Myoinositol also, we have to add it in the minute quantity. Okay. Yeah, myoinositol also, we have to add it in the minor quantity, right? To stimulate the cell growth, right? Amino acid, it's required for that growth. It's actually optional, right? If you want, if you feel we have to add more nitrogen, then we can go with the amino acids, right? It's in hydrolysate, glutamine, asparagine, adenine, we can add it, right? They are the source of organic nitrogen, right? Why we have to add amino acid? Because those that is a source of nitrogen which can be easily assimilated by the tissues and cells compared to inorganic nitrogen. Remember it, right? If you feel, that's not a compulsory one. If you feel we have to add nitrogen, more nitrogen, then we can go with that. Instead of increasing that inorganic nitrogen concentration, we can add little amount of casein hydrolysate. We can buy it, right? Adenine, whatever, glutamine, whatever, we can buy it and we can add it in the media, right? Because organic nitrogen supplements, they can easily assimilated by the plant cells and tissues, right? And the sixth one, undefined organic supplements, I already told you, these are actually optional. Instead of using the plant growth regulators, there are so many studies done with the undefined organic supplements, right? Coconut milk, yeast extract, malt, orange juice, tomato juice. We can add it and we can check whether those mostly in these supplements, the plant growth regulators are present, right? Coconut milk, coconut water, right? Cytokinin is present, so we can add it in the media, right? And that activated charcoal, these things I already teach you, just to recall the things, right? Activated charcoal we added mainly for the root, mainly in the rooting media, but we can't expect we can't expect the results what we expect actually, right? There may be some failures because normally what we think, activated charcoal absorb the inhibitory substances from the media. But in addition to that inhibitory substances, there are chances for absorption of plant growth regulators. right? So that situation we can't get the results what we expect, right? That may be happen, right? Why we have to add activated charcoal? One is that it provides the dark condition similar to soil. So it stimulates the rooting. And in addition to that, it absorbs the unwanted inhibitory substances, right? And the next one is the solidifying agent. For the semi-solid media, we have to add solidifying agent, right? Phytagel or agar, we can add it, right? And not for the liquid culture. Liquid culture, there only one difference in between liquid culture and semi-solid culture. For the semi-solid culture, we have to add agar or phytagel. The liquid culture, all the other compositions are similar except solidifying agent, right? Growth regulators, you know it, auxin, gibberellin, cytokinin, right? Commonly used auxins are for the callus culture, normally 2,4-D we use. Rooting, indole butyric acid, and acetic acid. Indole acetic acid also we can use. That is a naturally found auxin. We are going to study in the next class. Plant growth regulators, right? That is naturally found auxin. But we have to be careful when we sterilize. It will denature, right? So filter sterilization, we have to do it for the, if we add indole acetic acid, right? IAA. And the cytokinin, BAP, benzyl aminopurine, BAP, that is the commonly used one in the plant tissue culture, right? Kinetin also we can use, quite expensive. Those are Tiduceron also we can use. Tiduceron more expensive even than kinetin, right? So BAP, that's good. And so now we are going to study. We know what are the tissue culture media composition, right? What are the things it should consist, and now we are going to study how we are going to prepare the media, right? So just prior to preparing the media, right? First we have to prepare the stock solution, right? Stock solutions we have to prepare incorporating all the nutrients, right? Just here, the first column, look at here, the stock A, right? Those stock A consist macronutrients, mainly the nitrogen, right? Stock B, again macronutrients, I already told you, right? Nitrogen, potassium, manganese, phosphorus, calcium, these things, we have to add it in the stock B, right? And the stock C, micronutrients, right? Boron, manganese, zinc, like that, micronutrients, we have to add it in the, when we prepare the stock C. Stock D, iron, right? Remember, stock D is iron. Stock solution E is vitamins and amino acids, right? Vitamins and amino acids, we can add it in the stock solution E, right? So for the stock solution, we have to measure that ammonium nitrate, right? In the final, if you are going to prepare 1 liter of media, right? The tissue culture media, in the 1 liter, 1650 milligram of ammonium nitrate should be present. This is the what? Sorry. This is the one recommended by the Murshige and Skjuch. This is MS media, right? So Murshige and Skjuch recommended 1650 milligram of ammonium nitrate should be present in 1 liter of media. So in this column, right, in the final formulation, the 1 liter media should consist this amount of chemicals, right? For the nitrogen, here we use ammonium nitrate, potassium nitrate, right? So for all the things, we have to add these chemicals to get the nutrient, particular nutrient, manganese, magnesium sulfate, like that. We have to add nutrients, right? So for we have to how to say, for the nutrients we have to add these chemicals. So these chemicals should be present in the final formulation of MS media, right? So in that final formulation, right, in 1 liter, this amount of chemical should be present. Remember, these are in 1 liter. 1 liter, this is 1650 milligram, right? So now we are going to, each and every time we can measure these chemicals. For if we want to prepare MSM 1 liter of media today, we can't measure this amount of chemical and prepare 1 liter. It's a time consuming procedure. So what we do actually, we prepare to start the work. We prepare the stock solution. From the stock solution, we prepare stock solution and keep it in the refrigerator. Each and every time we take the stock solution and from that we prepare the media, right? Excuse me. Okay, do you remember, do you understand what I tell? Up to this third column, could you understand what I explained you? Are you hearing me?
Yes. Yes.
Just honestly say, do you understand this up to this third column? Just forget about the stock solution. What is stock A? What are the nutrients that what are stock solutions? Normally we prepare 5 stock solutions, stock A, B, C, D and E. Stock A and B contain macronutrients, stock C contain micronutrient, D contain iron, EDTA, stock E contain vitamins and amino acids. Right? For the macronutrients, nitrogen, we add ammonium nitrate. Likewise, for each and every nutrient, we add these chemicals, right? And in 1 liter of media, this milligram of chemical should be present. We have to measure. If we have to for 1 liter of media, if we are going to prepare in the final formulation, 1650 milligram of ammonium nitrate should be present. Likewise, this amount of this milligram of chemical should be present in the final formulation. Understand or not?
Yes.
Okay. Now we can see how to prepare the stock solution. With we see there are 5 stock solutions we can prepare, and here we are going to study how to prepare the stock solution, right? So as I told you earlier, each and every time we can measure. These are small quantity. 1650 milligram means 1.65 gram. Right? We have accurately measured 1.65 gram. Right? Just think, normally for a single plant, we prepare in one day, we prepare 2,000, 3,000 milliliter of media. 3 liter, 3,000 millimeter means 3 liter of. So each and every time, is it possible to measure all these chemicals and add it in the media? No, right? So for that, we concentrated all the nutrients, right? And prepare it. Prior to prepare the media, we prepare the stock solution. The stock solution contain the concentrated chemicals, right? In the concentrated form. We prepare it and we keep it in the refrigerator. We prepare there are conical flasks are there, right? These are actually practical, right? The conical flasks are there. What we normally do it, right? We prepare, there are 1,000 milliliter, we can prepare it. The small conical flask also there, right? For that stock C and E, we can take 500 milliliter of conical flask, right? Because they are small quantity, so 500 milliliter is enough. We can prepare the stock A, then we can mark it as stock A. Right, stock A, and the date of preparation, 31st of, if you prepare today, 31st of, right, December, we have to mark it. Likewise, stock E, what is the stock solution we prepare? We have to take a clean conical flask, right, and we have to pour it, and we have to label it with the date, and we have to store it in the refrigerator, right? That is the way of preparing the stock solution, right? Then, how to prepare the stock solution means we are going to concentrate it. These nutrients we are going to concentrate in the solutions, right? So if we are going to prepare 500 milliliter, actually we have to measure. If you are going to prepare 500 milliliter of stock solution A, we have to measure 16,500 milligram, tenfold higher than the final formulation, right? Likewise, macronutrients, we can add it tenfold, right? And we have to, if it is 16,500 milligram of ammonium nitrate, we have to measure it, and we have to dissolve in 500 milliliter of water, right? We have to measure 16,500 milligram ammonium nitrate, and we have to pour it in the conical flask and pour the distilled water, 500 milliliter of distilled water, and we can put a magnet inside, right? And we can keep it on the magnetic stirrer, right? Then the magnet automatically start to stir the solutions, right? And then until it fully dissolved, we have to stir it well on the magnetic stirrer. Thereafter, we can take it and we can label it, and if it is a conical flask, we can cover it with the aluminium foil and we can keep it in the refrigerator, right? The stock A is simple. The stock solution B, if we are going to prepare, right? Potassium nitrate, we have to take. This is tenfold again. Stock B, we have to prepare tenfold. So again, this is the final formulation. 900 1900 milligram should be present in 1 liter. Here, that concentration should be 10-fold. So we have to make 19,000 milligram. We have to take it, and we have to dissolve in 500 milliliter. Right? So just remember here we are preparing 500. All the stock solution we are preparing 500 milliliter. Right? So sometimes what we do, we prepare stock A, B, and D. Actually, we need more. Right? So what we do, we can prepare 1000 milliliter. A, B, and D only we prepare 1000 milliliter. Then what we do, we have to multiply this. This is for 500 milliliter, so we multiply by 2 for 1000 milliliter, and we can add it 33,000 milligram, which means 33 gram of ammonium nitrate we can measure and dissolve in 1 liter water. Right? Only for stock A, stock B, and stock D, we normally prepare 1000 milliliter. Right? But because it finish very quickly, right? These three, it's finished very quickly. So we prepare 1000 milliliter. If not, if it is for your easiness, if you want to prepare 500 milliliter for all the stock solutions, right? These stock A, B, and D, these are quite larger quantities, so we can just for tenfold concentration, we can prepare the stock solution. But these micronutrients and vitamins and amino acids, they are in the small quantity. Just here, see, this is in a milligram. So, really hard to measure this amount of micronutrients and vitamins and amino acids. So, what we can do, we can prepare 100-fold concentration for the stock solution C and E. Only C and E, 100-fold concentration we are going to prepare the stock solution. Right? Then if it is 6.2 into multiplied by 100, 620 milligram present in 500 milliliter. Right? These are the things we have to measure it and dissolve in 500 milliliter. Right? Just forget about the media preparation. Just here, this is the stock solution preparation. Right? A, B, and D only 10-fold concentration. We take them, we measure that chemical and dissolve in 500 milliliter. C and E, 100-fold concentration. We have to measure the chemicals and dissolve it in 500 milliliter water. Right? Now, our stock solution, A to E stock solutions are ready. Right? We keep it in the refrigerator. The next day, we are going to suggest, I may explain you further preparation of stock solutions, right? Preparation of macronutrient stock solution means stock A and B, right? So that is, we prepared in the 10-fold concentration. We have to weigh the ingredient as given in the table and dissolve one by one, make it 500 milliliter. If it is 1650 milligram of ammonium nitrate, right? Then what for the stock solution, we have to take it 10-fold, 16,500 milligram, and we have to dissolve it in 500 milliliter water. Here, one thing I forgot to mention, our stock solution A is not a matter, but stock B, we have to first measure the ammonium nitrate and we have to dissolve it. In this order, we have to add chemicals one by one, and until fully until we fully dissolve the chemicals, we have to wait it. And once the ammonium nitrate dissolve in water, we have to add magnesium sulfate. Right? Likewise, we have to add one by one, because if we add all, all together at a time, there may be chances for precipitation. To avoid the precipitation, we have to add each and every chemical one by one. We have to be careful when we add when we prepare stock B and stock C, right? And the stock solution, the preparation of micronutrient stock solution. What is the stock solution? How do we call the micronutrient stock solution? How do we call the micronutrient stock solution? Stock A or B or C or D? What? Stock solution?
C.
C, right? So earlier also I told vitamins and stock C, micronutrients, they are present minute quantity in the final formulation. So to make it easier, to measure it easier, we take 100-fold higher concentration in the stock solution, right? Then we have to measure each and every chemical 100-fold and we have to dissolve it in distilled water. Iron EDTA, that is stock D, again 10-fold, right? We have to measure it. We have to add it in the water, right? It takes a little bit time for dissolution, right? We have to keep it until fully dissolved on the magnetic stirrer. And the vitamin stock solution is also same, right? Vitamin stock solution as stock solution C, 100-fold higher concentration in the stock solution. So we have to measure it. We have to measure it very carefully. That accurate measurement is important, right? Because since all the nutrients are minute quantity, right? And we have to measure it accurately. We have to dissolve it in 500. Now we prepare 500 milliliter of stock A, B, C, D, and E, right? And in addition to the stock solution, we have to prepare the plant growth regulator stock solution, right? Plant growth regulators mean we already talked the BAP we need, right? Kinetin, cytokinin, BAP and kinetin normally we use. Auxins also, IBA, indole acetic acid 240. Right? So those are normally what we normally use for the routing. 1 milligram per liter of indole butyric acid, IBA. 1 milligram per liter. Just think, every time it's not possible to measure 1 milligram, and we have to dissolve it in alcohol or HCl or NaOH. We have to dissolve it. If it is an auxin, IBA, we have to dissolve it in HCl, right? Then each and every time that 1 milligram means a very, very minute quantity. It's really hard to measure. And it's really well, every time we have to add a small drop of HCl and we have to dissolve it, right? And we have to make it, pour it in the conical flask, right? And we have to volume of until 1000 milliliter. It's really hard. So what we do, in the nutrients, microvitamin, for the hormones also, we prepare the stock solution. Right? Understand or not? Understand or not? Yeah. Then we have to prepare the stock solution. Right? We have to measure, for an example, 10 milligram per liter. We can make 100 milligram, 10 milligram of, we can measure 10 milligram of oxide. and we can dissolve it in 100 milliliter, and we can we have to dissolve it in the HCl. At the minute quantity of HCl or NaOH. It depends on the, because hormones are not directly dissolved in water, right? For the dissolution, we have to add alcohol or HCl or NaOH, right? We have to just a drop, we have to add it, and we have to dissolve it using a small spatula, right? Once it fully dissolved in that HCl or alcohol or NaOH, we have to carefully pour it in that volumetric flask, and then we have to volume up using the deionized distilled water, right? Under that mark, I can show you what is that. Volumetric flask, right? You know it. Normally, for that plant growth regulators, hormone, we use volumetric flask, right? For the stocks also, we can use volumetric flask if it is adequately available. Otherwise, we can use normal conical flask, right? These are conical flask. We can, the 1000 milliliter is available, right? If we are going to prepare all the stock solutions in 500 milliliter, we can take 500 milliliter of conical flask, right? We can pour the, we can measure and pour the chemicals in this one, and we can volume up, right? And we have to label the stock solutions, right? What is that? And date of preparation. All the things we have to include, right? And if it is a plant growth regulators, we have to mention here 10 milligram. What is the plant growth regulator? IVA or NAA or 240 BAP, whatever. We have to write it on the conical flask by using that marker, and then we have to we have to mention the concentration. For an example, 10 milligram per 100 milliliter, right? And then we have to put the date of preparation, right? Because these plant growth regulators, other stock solution, we are quickly finish it. But the plant growth regulators, what will happen? According to the need, we add small quantity, right? Sometimes we have to check it prior to use it. Are there any fungal growth? Sometimes when we pipette out every time, if the pipette has some contamination, then the fungal starts to grow in the plant on the plant growth nutrient. Plant growth regulator solution. We have to check it for all the stock solution prior to use it. We have to check it. Are there any fungal growth, right? Because when we are using the pipettes, we have to use clean pipette. Pipette every time we have to carefully wash it, right? 3-4 times we have to use take that water inside the pipette by using that sucker, and we have to release it, and we have to thoroughly rinse with the water until all the minute things are removed, right? Pipette, that is the source of contaminants, right? We have to carefully wash it thoroughly, and then we have to put it in the oven, and then only we have to keep it on the pipette stand, right? Hope you know what is pipette. Right? Normally we have to put it in this stand, right? Pipette stands, right? 10 milliliter, 2 milliliter, 1 milliliter, 100 milliliter, 50 milliliter, 20 milliliter. All the pipettes we can use it according to the needs, right? Right? This is the Okay. Understand or not?
Understood, madam.
Okay. So this is now we prepare. Now our stock solutions are ready, and now we are going to see. Now stock solutions are ready, right? But now we are going to, just for an example, we are going to prepare 1 liter media today for the tomorrow's work. Right? Now we know what is the final formula. 1 liter final formulation contain how many milligram of each and every chemical. But the stock solution concentration also we know it, right? So we have to calculate what is the volume of stock solution we have to prepare out to make the 1 liter of media, right? For an example here, stock solution A we prepared. Stock solution A contain ammonium nitrate, but 1 liter of basal media, the final formulation, it should contain 1650 milligram. But what is the stock solution we prepared? We prepared 500 milliliter of stock solution, right? In the stock solution, ammonium nitrate amount is 16,500. Tenfold higher concentration, we take it and dissolve it in 500 milliliters of solution. Right? So what is the volume of stock solution we have to prepare out to prepare 1 liter of media? We want to calculate it, right? This 500 milliliter contain 16,500. So to make it 1650 milliliter, what is the volume we have to pipette out? This is the one. This is the volume we have to pipette out. When we calculate this one, we can get the V is 50 milliliter. Right? The 50 milliliter we have to pipette out from the stock solution, right? And we have to pour it in another beaker to prepare the 1 liter media. Understand or confusing in understanding? That this is the one actually sometimes. Okay, this is the basal media. Then 1 liter basal media we are going to prepare. 1 liter media we are going to prepare for tomorrow's work, right? But we don't. We have stock solution, right? We already prepare stock solution. 500 milliliters of stock solution we already prepared. So the 500 milliliters stock solution A, it contains 16,500 milligram of ammonium nitrate. And these two steps, understand or not? Understand or not? If it is not, just let me know, please. Couldn't you understand?
Yes, ma'am.
This is how we prepared, right? 500. We prepared 500 milliliter of stock solution. Now we prepared 500 milliliter of stock solution. We add tenfold higher macronutrient and EDTA. We add tenfold higher in the 500 milliliter stock solution. 100-fold higher solution we add it in the stock C and E. Just see here 6.2 multiplied by 100, right? 620 milligram. all the chemicals we multiply, all the micronutrients and vitamins we multiplied by 100 and we dissolve it in 500 milliliter water, right? This is the one that 500 milliliter stock solution consists. This is the amount of chemical the 500 milliliter of stock solution consists, right? So, but now just forget about that pure chemicals, right? We are going to take the stock solutions. We have to pipette out particular volume to prepare the media. The stock solution consists the nutrients now. We have to pipette out the stock solution, the required volume we have to pipette out, and we have to make media, 1 liter media. For an example, 1 liter media. Right? Understand or not up to now?
Understand, ma'am.
Understood.
Okay. So here, according to that already prepared stock solution, the 500 milliliter, the ammonium nitrate present in 16,500 milligram. Right? This is how we prepare the stock solution earlier. Right? So what is the volume of stock solution? We have to pipette out to prepare 1 liter of media. How do we calculate it? Simple calculation. The 500 milliliter stock solution consists 16,500 milligram of ammonium nitrate. So if we in which volume we take, we can get 1,650 milligram ammonium nitrate, because the 1 liter we are going to prepare, the 1 liter media should consist 1,650 milligram ammonium nitrate. So if we take the particular volume of stock solution, it should contain this 1,650 milligram ammonium nitrate. So when we are calculating this, right, we mean, I don't know whether you can, it's really hard to understand these things by using this PowerPoint, right? Here V equal to 1,650 500 16,500. It's really hard to write it. Right? Then V equal to 50 milliliter. So if we pipette out 50 milliliter of stock A, right? If you pipette out 50 milliliter of stock A, it contains 1,650 milligram of ammonium nitrate. Right? To prepare 1 liter of media, 1,650 milligram, that media should consist of ammonium nitrate. So if we pipette out 50 milliliter of stock solution from the already prepared stock solution, if we pipette out 50 milliliter from that, it contains 1,650 milligram ammonium nitrate. Understand or not?
Understand.
Yes. This calculation is same for the stock B and D, right? That because that same kind of that for an example, stock D contain EDTA. EDTA present in 1 liter media is 1 liter media is EDTA present in 1 liter media is nearly this 373 and 288, right? So right? Then when we calculate according to this step, this required volume is 50 milliliter for B and D, right? But stock C and E is quite different, right? For an example, this is why I explained this one, because this stock A contain only one nutrient. It's easy to understand. Stock C, B, D, C and E, all with the stock solution, it contains more than one nutrient. So that explanation is quite hard, right? That stock C and E, it contains micronutrients stock C, vitamins and amino acids in stock E. So then we can add, we can put it Y milligram altogether, Y milligram of micronutrients or amino vitamins and if it is stock C, just forget about the E, stock E, micronutrients present in 1 milliliter of basal media is Y milligram. Yeah, because there are 6 or 7 micronutrients are there. Then we can all together combine and make an Y milligram, right? But amount of micronutrient present in 500 milliliter, what? 100-fold. For stock C and E, I told you 100-fold we added. We concentrated by 100-fold. Why? Because those are very minute quantity. It's really hard to measure. So we add more concentrated form, right? So in 500 milliliter, we add 100-fold. We add all the nutrients in 100-fold. Yes or no?
Yes.
Then what is the amount of micronutrient present in 500 milliliter stock solution C? 100 pi, right? Yes or no? 100-fold higher, no? See,
yes.
Here 6.2, we multiplied by 620, 100-fold, right? Then so required volume of stock C prepared out from 1 liter media is 5 milliliter, right? For 500 milliliter, 100 by %. So in which quantity we have to pipette out to bring it? Y milligram. Then we calculate as this, we can get it. V1 is 5 milliliter, right? This is for 1 liter media. Sometimes we may prepare, we have to prepare 2 liter. 2 milliliter media, we have to prepare it. So in the 2 liter media, 2 Y should be present. But amount present in 500 milliliter, this is same, 100 Y. So if we want to prepare 2 Y, V1 should be 10 milliliter. Yes or no? If it is chalkboard, it's really easy for me to explain. This is for 1 liter media, no? This calculation here we are preparing 1 liter media. 1 liter media should contain media contain 1650 milligram ammonium nitrate. If it is 2 liter media, if you are going to prepare 2 liter media, the 2 liter media should contain, it's double, no, 33,300. Yes or no?
Yes.
Stock solution, same concentration. This is the concentration we prepared in the prepared stock solution. In this concentration, we prepared stock solution. That 1 liter basal media should contain this amount. But we are going to prepare 2 liter of media. 2 liter of media should contain 3,300 milligram of ammonium nitrate. Then how many milliliter of stock A we have to pipette out? 100 milliliter. Yes. Right? Yes or no? Okay. Then if just for an example, this is if we are preparing 500 milliliter stock solution, stock A, B, D, we have to prepare out 50 milliliter. C and E, we have to prepare out 5 milliliter. So if we are going to prepare 1.5 liter, 75 multiplied by 1.5, 75, 75, 7.5, 75, 7.5. This amount of stock solutions we have to prepare out and pour it in one beaker, right? And then we have to volume up. If it is 1.5 milliliter, 5 liter, we have to take 2 liter beaker. We have to add each and every stock solution one by one. Stock A first, stock B first, C, D, and E, right? And we have to add a little bit of water, and then we have to add the sugar, 30 gram, sorry, not 30 gram, 30 gram for 1 liter. 1.5, 45 gram. We have to add 45 gram sugar, and then we have to add for 1 liter 100 milligram inositol. For 1.5, 150 milligram, which means 0.15 gram. We have to measure it and pour it in the beaker. Put it in the beaker. It's in a powder form, white powder form, right? And then we have to put a magnet and keep it on the magnetic stirrer until it fully dissolves. And then again we have to add, if you want to add BAP, then we already prepared the stock solution BAP. From that, the required volume of BAP we can take it, right? We can prepare out it and put it in the beaker, and then we have to volume up with the deionized distilled water up to 1.5 liter, right? Understand or not?
Understand, madam.
Right? Same as BAP 240 also. Normally we prepare 10 milligram. 10 milligram we take it and make it 100 milligram, so 100 milliliter BAP 240, right? So that is stock solution. So if we are preparing 1 liter or 1.5 liter medium, how many milliliter of BAP stock we have to prepare out? We have to calculate that one also, right? And then now we prepare the media. We have to measure the pH, and we have to adjust the pH 1.8, 1.75 to 1.85, okay, but 1.58 is the one, right? We have to adjust the pH until 1.8. If it is low pH, we can add a little bit of NaOH, right? The higher pH, HCl, little bit, pretty minute, and we can bring it to 5.8, because in this pH the absorption of nutrient by the plant part is high, right? So we have to adjust the pH until it comes to 5.8. 1.75 to 1.85 is okay. Then lastly, after measuring the pH, we have to add the phytagel or agar. 3 gram per liter of agar. Normally we can phytagel we can add it. Then 1.5 liter, if we are going to prepare, then 4.5 gram we have to measure it and we have to add it, right? And once we have add the phytagel, we have to keep it in the microwave oven until it fully boil, because the phytagel should be dissolved in the water, right? So the normal magnetic stirrer is not enough to dissolve it. So the phytagel, when we heat up only, the phytagel dissolve with the media. So to heat up, we normally use the microwave oven, right, until it fully dissolve, right? When the media starts to boil, all the phytagel dissolve in the media, and we have to take out, right? It is really very hot, the media we have to take out, and we have to pour it in the small glass bottles or tubes, flat bottom tubes are there. We can pour it. Then we can allow to cool for a few minutes. Then we have to put the cap or that lid. If it is bottle lid, right? If it is small conical flask, then we can use some cotton plugs, right? And cover it with the aluminium foil. And then we have to keep it in the autoclave. Autoclave for what? For sterilization. Okay? That is the one. Understand or not?
Yes, ma'am, understand.
Then okay, don't worry, I will explain one more calculation for the media preparation next class, right? I will give you an calculation part. You try it, then I will explain. Okay? Otherwise, okay, no, I will explain one example, then I will give an assignment, submit it. Okay? Okay. Then we can stop here, right? I will let you know the next class, right? Plant growth regulators. Before that, we can do some calculation with that media preparation. Okay?